All right, hey guys. So today's notes, I don't necessarily think you need a video, but if you did struggle with completing the square on the test, this is just a great video to watch me review that. For this first two questions, though, these are just foiling questions. So it says transform the following quadratics into standard form. Here you're going to, in order to do this, we'll have to use our foiling skills. Be sure to follow the order of operations. So if we're doing order of operations, you need to do this first, right? But in order to do that first, you need to first split the parentheses. So it's x minus 1 squared would mean x minus 1 times x minus 1 plus 9. Okay, the most common mistake people make is they think they can distribute the 3 in there, but you can't do that until you FOIL everything in the parentheses together. So we get y is equal to 3, x squared minus x plus 1 plus 9. And that's going to be y is equal to 3, x squared minus 2x plus 1 plus 9. Now we can distribute that 3 into everything. So that would give us y is equal to 3x squared minus 6x plus 3 plus 9. So then our final answer to get this in standard form, we just combine those last two terms. Y is equal to 3x squared minus 6x plus 12. Now this would be our answer in standard form. To the right here, it's going to follow the same exact order here. We're going to go negative 2. X times x gives us x squared, negative 3x, positive 7x, negative 21. Now we can distribute the negative 2. Or actually, let's combine some terms first. Y equals negative 2, x squared minus 10x minus 21. Negative 2, negative 2, negative 2. So y is equal to negative 2x squared plus 20x plus 42. And then we would be done as soon as we distribute that negative 2, because there is no two terms at the end there. Sweet. So for the next one, it says transform the following quadratics into vertex form. Use the completing the square process. We have done this already. So completing the square is not bad when the a value is 1, right? When the a value is 1, you literally just do x squared minus 4x plus blank minus blank plus 7, and now we complete the square. So negative 4 divided by 2 is negative 2. Negative 2 squared is positive 4, so we fill in those, positive 4. And now here's our perfect square trinomial. So we say y is equal to x minus 2. Remember the minus 2 comes from our b value divided by 2, squared, and then minus 4 plus 7 is going to become positive 3. And now we're in vertex form. All right, so for the next one here, now these ones are the ones that get a little bit trickier because now we have an a value. To start these ones, you divide the a and the b by the a. So that we're going to factor out the negative 3. That's going to leave us with x squared minus 2x, or sorry, plus 2x because negative is positive. Now we put the plus blank and the minus blank. The negative 4 just gets pushed to the very end, so minus 4. And now we complete the square in the parentheses. 2 divided by 2 is 1. 1 squared is still 1, so we fill in 1s. We now have a perfect square trinomial right here. So we go negative 3, x plus 1 squared. All right, and then we have negative 1 still in the back. Negative 4 outside of the parentheses. Now we're going to distribute the negative 3 in that parentheses. So we go negative 3, x plus 1 squared plus 3 minus 4, which would give us an answer of y equals negative 3x plus 1 squared minus 1. Just like that. All right, and that's how we go to vertex form with an a value. All right. Next one here, it says transform the following quadratics into intercept form. This means put the equation in their factored form, identify the x-intercepts when completed. Okay, so whenever we're factoring, looking for greatest common factors, which all of these are divisible by 2. So that moves 2 to the front. You get 3x squared plus 5x minus 2. So then now we can factor it. So it's 3x and x. We have 1 and 2 are the only options here. We need positive 5. Something in positive 6. Okay, so that should be good, actually. Double check. 6x, negative x. That does give us negative 5, or positive 5. So we are solid right here. And then lastly, number 6 right here. Here we have a 5 comes out of both, so 5x squared minus 4. X squared minus 4, perfect squares, the difference of them. So 5x plus 2, x minus 2. And then that's as far as we can take it. All right. And then last but not least on these notes is going to be just a quick refresher of end behavior. So it says describe the end behavior for the quadratic functions by completing the following notation, right? As x goes to negative infinity, which this is saying as our x's go to the left, f of x goes towards where, or y's go towards where. As x goes to positive infinity, so this is saying as our graph goes to the right, where is f of x going? So for these questions, you want to take a look at the equation and kind of decide what's going on here. So we have positive a value. That means it's opening up, right? So it's going to look something like this. And that's really all you need. So as x goes to negative infinity, so as x goes this way, where's our y's going? Going towards positive infinity. As x goes towards positive infinity, so to the right, where's y's going? Also going to positive infinity. For all quadratics, these two should match. They're either going to be positive, positive, or they're going to be negative, negative. And it's all based on the a value, right? So a value of negative 2 tells me it's opening down. Doesn't matter how, it's opening down. So as x goes to the left, we're going towards negative infinity, right? And as x goes to the right, again, we're going towards negative infinity. Okay? And that's all the notes for today. It's just a little bit of review. Hopefully this went super smooth for you guys. As always, if you have questions, message me on Canvas. Have a great rest of your day.